inverse relations and functions. I'm not going to read the learning intention out, but I am going to expect you to pause it and make sure you read it yourself. So what an inverse is, first of all, let's just consider any ordinary old function f of x. And f of x is going to be equal to 2x plus 3. Right, so if I take f of 2 and sub it in there, I'm going to have 2 times by 2 plus 3, which is going to be equal to 4 plus 3 equals 7. I could equally take f of 3, which would be 2 times by 3 plus 3, which would be equal to 6, 9. Right, so what we've done there is taken a set of numbers, let's depict that here, the domain. We've taken some x numbers, and in this case we've taken the number 2. Let's say that 2 sits in this set of numbers here. This is 2, and then we've mapped that over to some different values over here in the range. Right, the range is over here, and we've taken this number 2 and we've shuffled him across, we've mapped that over here to some other number which is 7. Similarly, we've taken the number 3 here and mapped that over to 9 over here. Let's say 9 is somewhere here, like this. And in doing this mapping, we've used the function f of x to get there. We've used f of x to go from 2 across to 7. And so if we want to think about the range, I think the best way to, the inverse, if we want to think about the inverse, I think the best way of thinking about the inverse is going in the opposite direction. So taking this number 7 and saying, alright, well, how do we get back to 2? Right, or taking this number 9 and thinking, how do we get back to 3? And some notation, which we'll look at a bit later on, is f of negative 1 of x. Right, that guy would be f of negative 1 of x in there. So I think the next question we've got to ask ourselves is, alright, well, how do I find... So I think the next question that we've got to ask ourselves is, how do I find the equation? The inverse equation. Right, and thankfully this is relatively easy in most cases. The inverse equation, let's go back to f of x, our example from before. What do we have? We had 2x plus 3. The inverse, what we know is that the inverse of times is divide, and the inverse of plus is minus, and etc. What we can do is rewrite this guy as y is equal to 2x plus 3. And so when we're taking the inverse, as hopefully we'll see later on in a graph, we have to swap the x and y coordinates and then rearrange. Right, so the inverse equation then would be x is equal to 2y plus 3. And now I need to rearrange so that y becomes the subject. Alright, and so to do that we need to do the inverse to undo these things. So we're going to take away 3 from both sides, and we'll end up with x take 3 is equal to 2y, because subtract is the inverse of this plus here. And then we've got 2 times by y here, and so the inverse of times is divide. So I'm going to divide both sides by 2. Right, and so then what we're going to end up with is x take 3 over 2 is equal to y, or y is equal to x take 3 over 2. And what we can do then is define this guy as, and this is where our notation comes in. This guy becomes f of negative 1 of x, which is equal to x take 3 over 2. Or another way of writing that, sometimes it's easier, is x over 2 minus 3 over 2. And that's f of negative 1. So for the sake of clarity, let's take a look at a graph of f of x and its inverse, f of negative 1 of x. So we've got ourselves some Cartesian coordinates here. Let's label those guys up. So first off, I'm drawing f of x. F of x was equal to 2x plus 3, rather than yellow. So we're going to have a y coordinate, a y-axis intercept at 1, 2, 3 up here, and then a gradient of 2, which that means we're rising 2, 1, 2, and running 1. point about yay. And so let's draw that line through there. It's not my best work, but you get the idea. And then we need to draw a half, so the gradient of f of x, inverse of x is, I'm going to rewrite this as half x minus 3 over 2. So I'll have a intercept at, y-intercept at negative 3 over 2. There's negative 1, negative 2, so it's going to be there. And then a gradient of a half. And so that means we're rising 2. So it'd be negative a half, and running, no, sorry, we're rising 1 and running 2. 1, 2, so we'll have a point there. Again, if we go and draw this, just again, got this guy here. So this is f of negative 1, and then this guy is f of x, or just regular old f. Right, and so what ends up happening here, what's the relationship between these two guys? These guys are actually reflected about the line y is equal to x. Right, so this is the line y is equal to x here. And so what we did, if we put a mirror along y is equal to x, we would end up having f of negative 1. Right, so that's been flipped there, and that's why the method here of switching the x and y's ends up actually working. The other really useful thing here is that that the domain of f becomes the range of its inverse, and the range of f becomes the domain of its inverse. So the range and domain switch when we switch the x and the y. Another way of saying the same thing here is that the domain. Another way of saying the same thing here is that the domain of f is equal to the range of the inverse, and that the range of f is equal to the domain of its inverse. Sorry, and that there is meant to be the domain of its inverse, f of negative 1. Domain of f of negative 1, like that. And that's meant to be the same thing, but range. So the next thing we're going to look at is when an inverse function exists and when doesn't exist. There are two important considerations in this. The first one is that f can only have an inverse if f is a function. Now, if you remember, it is only a function if it passes the vertical line test, VLT, right? The other important consideration here is that the inverse of f, is f of negative 1, is only going to be a function itself if f is a one-to-one function. That means that horizontal and vertical line test, one-to-one. And let's just have a look at y. We can consider this guy here. The blue is y is equal to x squared, and then the red is the inverse of that. Alright, and so we can see that y is equal to x squared passes the vertical line test. We can see that here, passes the vertical line test. And so its inverse exists. This is the inverse here. It does work. If it doesn't pass the vertical, if this didn't pass the vertical line test, we'd be able to discover that this wouldn't exist. And I won't show you an example of that now. But what we can see is that this guy is a one-to-many function. Right? Vertical line, horizontal line, one-to-many. And because it's a one-to-many, the inverse here in red is not a function. Right? It's not a function because it does not pass the vertical line test once, twice. So turning now to an example, we've got a linear function here. We've got to first of all state the domain and determine the range. So this one we can just state the domain. We should remember that reading this function, the domain we can simply read off. So the domain of, that's an A, the domain of f is equal to close bracket 3 inclusive, close bracket is inclusive, bracket, close bracket. The range of f, we need to try and substitute some points in. So to find out the range, we can't just read out that's the codomain, that's the values of y that we can put into the function, not the values of y that end up being on the graph. Right, so to first up find the 1 point of the range, we'd have to sub in the point 0 into f of x. So f of 0 is going to be equal to 2 times by 0 take away 2, which is equal to negative 2. And that's an inclusive point because 0 is mapped to negative 2, and that's at inclusive, or close bracket. To find the other one, we need to say f of 3. So 2 times by 3 take away 2, which is 6 take away 2, which is equal to 4. And that's going to be exclusive, or a circle bracket. So therefore our range is going to be from negative 2 to 4. And that bracket maps to that bracket, this bracket to that bracket. Sorting out the domain range of f of negative 1, the inverse of f, as we've said, the d of f equals the range of f take 1, and r of f is equal to the domain of f take 1. So the domain of f is equal to the range of f take 1. So we're going to know that the r of the f take 1 is going to be equal to the domain of f, 0, 3. The domain of f take 1 is equal to negative 2, 4, close bracket. Cool, that's nice and easy. Moving on, form the rule of the inverse and express the inverse function in mapping notation. Alright, let's take a look at this. So what we're going to do is swap x and y and rearrange. To make sure we communicate this clearly, what I'm going to do is write, let's scroll down a little bit, let f of x equal to y. Right, because the original function f of x, which is equal to 2x take away 2, was equal to f of x, not equal to y. But for the sake of this, we need to have y is equal to 2x take away 2. Right, and so that's the function. The inverse is then going to be that swapped. So the inverse will be x is equal to 2y take away 2. That's the inverse. Right, so we've now got a relationship or an equation for the inverse, but we need to have y up the front because that's what we're used to. So we're going to add 2 to both sides, which means we're left with x plus 2 is equal to 2y, and then we'll divide both sides by 2, and that'll leave us with, I'm going to rewrite this slightly differently. If you need to work it out yourself, do half x plus 1, because 2 divided by 2 is equal to 1 is equal to y. Right, and then we just rewrite that the other way, y is equal to half x plus 1. Now the question isn't quite answered because we now need to write it as mapping notation. Right, so to get this guy into mapping notation, so to then write that in mapping notation, we need to have the name, which is, that should be in blue, f of negative 1. And then after the name, we have the domain. Now the domain we worked out before was negative 2 to 4. And the codomain is all the real values, the values that we can put in. And then the rule, f of negative 1 of x is equal to a half x plus 1. And then let's put ourselves a box around him. And that's formal mapping notation, the domain, the codomain, and then our rule. So the last thing we're going to do is sketch the graph of both functions, what you can see is I've got f of x, which is equal to 2x take 2, and that's the blue line here. The negative 2 is the y-intercept, and then I've seen that the gradient is equal to 2, which is equal to 2 over 1. So from there I've risen 2 and run 1, which has gotten me my second point there, and sketched the line from there. The other one, the y-intercept is positive 1, the gradient is 1 over 2, so from positive 1 I've risen 1 and run along 2, and sketched a line from there. To finish up, we have some definition, a definition, so make sure you get that in, and otherwise we'll see you in class. Good stuff, guys.